My name's Phil. I'm a representative from Lumin Smart Panel. We manufacture the Lumin Smart Panel. So I'm going to take you through just our basic deck. We take your ordinary load center, standard, square D, Siemens, whatever you prefer, and we are adding intelligence to that load center. So the way in which we do that is we have our Lumin Smart Panel. It's 17 by 17 by 4 inches of depth. You have pre-wired circuits and a 2-inch conduit coming out of the Lumin panel. That conduit is rotatable 360 degrees. If you need to come into a side knockout, bottom knockout, for some reason top knockout, that's totally fine. And we're going to have all of our control lines coming out of the pre-wired whip. So we are US made. At this point, actually I think that 40 plus is, well, I guess the plus gives us a little wiggle, but I think we're in all 50 states. And we have over 300 certified installers in our network. You can see here it can also be flush mounted underneath, or it can be surface mounted into a side knockout. Either is totally fine. The primary use case for what we do is load shedding. What we're trying to do is reduce the total load at the moment of an outage so that you don't overwhelm your storage system. Well, backup system. We are actually, that's a pretty critical note, we are agnostic to any of the surrounding equipment, meaning if you have a generator for backup or if you have a battery for backup, that's totally fine. You're going to be able to input your capacity into our software and we will hold your load below it. Secondary usage, we're also monitoring all of our connected circuits. I'll go a little bit more into the install method, but we're monitoring all of your connected circuits. While we are not an overcurrent protection device, we do provide some safety features. Say you leave your oven on when you're on your way to the airport. Instead of missing your plane, you can go to your app and turn it off. Same goes for a curling iron, it just depends on your preference. And you can also schedule circuits. Don't know if there's much time of use tariff structures in New England yet, but certainly they are coming. And so any of the connected circuits can be scheduled to not run during peak pricing times. Is that an issue?
Not as of yet.
We don't have a lot of them.
Okay.
I'm sure it's coming.
Mm-hmm.
So goes California, right?
Right.
Any of their connected circuits, they can also be scheduled to not run during peak pricing times. And of course, those controls can be overridden manually at any time. So a little bit on the installation, very, very straightforward. Once you have all of your conductors into the load center, you are subverting your traditional model of circuit breaker to load by going circuit breaker, our conductor, and then splicing the old line that was unscrewed from the circuit breaker onto the load. So in that way, your electricity path is going circuit breaker to Lumin panel to load, and we have a latching relay inside of our panel that can open and close programmatically and manually. Remote control, via cloud, via local connection, whatever your preference is, you can control your energy that way. So a little bit of notes about that. There are 12 lines of control. Very important note, a dual pole circuit will take 2 of your 12 lines. A single pole circuit will take 1 of your 12 lines. So in the software, you have to pair your dual poles. If you use Lumin Circuit 1 and Lumin Circuit 5 to control your stovetop, then you need to pair those in the software, line 1 and line 5. We see some tech support issues, where people say like, oh, I've paired line 1 and line 2. It's like, well, okay, you paired your fridge and your AC. Neat. So there are 2 sensor boards inside the Lumin panel. Actually, I guess this is probably not close enough to see, but there is an exploded view if you take a data sheet later. The 2 sensor boards, one is 60 amp rated, one is 30 amp rated, and each one has 6 relays. So you have 6 relays or 6 lines of control that are rated up to 60 amp. You have 6 relays or 6 lines of control that are rated up to 30 amp. Typically, you're using your 60 amp for your 240 loads, your 30 amp for your 120 loads. So it's going to control anywhere between 6 and 12 circuits. They are
those stackable?
Yes, they are. So they are stackable, technically infinitely stackable. In practice, you probably don't want more than 5 or 6. I mean, if you have that many breaker spaces in your home, that's impressive to begin with. But after about 5 or 6, you're putting so much data onto the internet connection that you might really cause some problems for your homeowner. But it is, in theory, possible to go infinitely. I think our biggest install is 16 Lumin panels on one site, which has its own set of complications, but it is doable. So yeah, they are stackable. Typically, you're not going to need more than 1 or 2. Philosophically, what we're trying to do is control the heavy loads and really just let the lighter loads run on their own. We're figuring lighting circuits, smoke alarms, these are probably not going to need circuit control. Whereas a water heater or an HVAC very much could. So pretty critical note. Well, let me talk about comms first. It is communicating over Wi-Fi, or it can be hardlined. We have an RJ45 port in the Lumin panel. If you communicate over Wi-Fi, it's 2.4 only. So if you have one of these, very fancy mesh networks, it can be a little hard to push out a 2.4. That's a consideration that we get on tech support sometimes. But generally, you're going to have availability. We choose 2.4 because of its range. We want to be able to communicate over distance. So that's the reasoning there. And then last note, we take a philosophical approach in that we want to be agnostic to all of the other equipment. I mentioned earlier, if you have generator as backup, it's no different for us than if you have battery as backup. Part of that agnosticism means that we need to get all of our own metrics by ourselves. And so the way in which we recognize a grid outage is to actually reach a reference outside of the backup system. So we are taking a conductor and we are attaching it in a whole home backup. Of course, this is different for a partial home backup. But in a whole home backup, we're taking a conductor, we're attaching it to the supply side as a voltage reference. As soon as that voltage goes from 120 to 0, we recognize a grid outage has occurred, and we go into our load shedding protocols. So while this is a DIY-friendly product, that specific application for whole home backups will require a supply side connection. Please have a qualified professional on hand. Right?
Who's a Lumin installer or just a general electrician?
So our, don't cross your arms. So our certified installer training actually is going on right now. It's every Thursday at 11 a.m. Eastern time. It's a 60-minute course. We highly, highly recommend that people take it. Ultimately, none of this needs a certified installer. It's relatively straightforward. I lovingly talk about the Lumin panel at times as 2 standoff brackets and 12 wire nuts. But we would really prefer if people took our installer training.
Yeah, right on.
It is a remote class. It's once a week for just an hour. And if you're going to install more than one, you'll be happy you did it. Actually, shoot, if you're going to install one, you'll be happy you did it. Moving on a little bit, the general idea of a Lumin connected system is typically for your backup systems, your storage systems, you're going to take a critical loads panel, you're going to move a few light loads into it, and then the battery will power the critical loads panel, which is great, but it does have a hard remove from some of your heavier loads. What we're doing with the Lumin panel is to not connect to the lighter loads, but then have the ability to shed at the moment of outage all of those heavy loads. So they would all come off, and what's left in the main service panel is going to be your light loads. That being said, if you want to utilize those heavy loads, you have the ability through software to do so. So you can control that relay at will.
Like on your app, you can touch which ones?
Yeah, actually, I can show you. This is an example of our app. We'll go into this a bit more later, but toggling this circuit, you can control the circuit however you want.
Fancy.
So this is an example of an installation by our buddies at NEC. If it'll load. So obviously super sped up, does usually take about 2 to 3 hours, but you're sending all those conductors into the service panel, and then you're just unscrewing from your circuit breaker, replacing it with our wire, and tying a wire nut to make it part of the circuit.
And then those blue, is that going conduit? Oh yeah, there it is.
Yep.
Right on.
And so this is what a finished product would potentially look like. You see, it's just right next to the load center, and it can connect to main service panel, sub panel. You can extend those wires and put it somewhere else completely. Flexible product is the idea.
And that's it's run by Bluetooth. It's run by.
I'm sorry.
The app is running through Wi-Fi.
Actually, that's a good question. So the default communication protocol is local, and all the settings are stored locally. So you don't need cloud connectivity, but the data, the historical data, will only be available if there is a incoming service, internet service. I mean, but if you have the modem and router backed up in your loads, and you have a local connection within the house, you can still control all of the settings. You just don't have the historical data. Yeah, go ahead.
And I may have missed it, but do you have any interface with the battery system so that if you're
Right.
below a certain percentage,
Yeah.
automatically cut out your...
We do, but it's limited. Getting that state of charge information is based on an API integration with the manufacturer. So we have that for Enphase and SolarEdge. We're working on a few other partners, but right now just Enphase and SolarEdge.
And how does that communicate?
Cloud. So if the ISP goes down during the outage, we don't have that data anymore.
Are you working on a hardwired?
Working on it. Yeah.
Does the Lumin panel come with those jumper wires, or those installer supplied?
Jumper wires?
Blue wires.
The blue wires.
Yeah, everything's pre-wired. Yeah, everything's pre-wired.
Similar to like a gen train thing.
I'll take your word for it. All right, let me see if I can figure out how to move on. Okay, so this is just a few different screens of our software. This is your main home screen. All of your connected loads are going to represent as a tile. You can click on any one of these for individual circuit data. You can also click on the Insights tab here, and you'll have a graph of all of your connected circuits. And then if you'll note here, this might be a little small to see, but we do put CTs on the service conductors to measure the consumptive load. And so while we're giving you individual circuit monitoring of your connected loads, we do take a total consumption metric as well. This is our scheduling, and then we also have a sort of hierarchy of priority in our off-grid mode, which I will show you now. So here you can see in the app screen, these are all of our connected loads. Let me turn the feature on. And we have them broken into 3 categories. Essential. Essential means that they are not going to load shed. So when an outage happens, these are going to stay on. We're going to make sure they do. You have your optional. This is more of an elastic category in that these could load shed depending on your output capacity, or maybe they stay on depending on your output capacity. And then your undesired, these are the loads that will automatically shed as soon as we sense a grid loss. So we have input here a limit of 6,800 watts. That's what our inverter is capable of outputting. And so when an outage happens, we're going to take our 21 kilowatts of usage, roughly, and shed that down to where the inverter is capable of. So this is, when I say this is an elastic total, right now we have the water heater ranked in priority above the air conditioner. So the water heater is using 4,000 of our available 6,800 watts. As soon as we are done using the water heater, the other circuits below it in a lower priority are allowed to use power. So if we were to start another hot shower, then those circuits would then be shed. And so we're always staying below that output capacity to make sure that we're not going to cause a nuisance trip. And then of course when the outage is done, everything is allowed to come back on.
And that's all automatic, you don't have to...
Everything's automatic, it just has to be programmed at the time of commissioning.
Going to be changed?
Yeah, actually.
Commissioning, I just want to be sure.
Yep. So this would be like the end user screen. And so they could go into this and in real time, they could say, you know what? I need to get to the grocery store. Let me put a little juice in my EV. And actually it still might be too big, but let's try it. So yeah, and then you can use the EV to get you 10, 15 miles of charge and go on down the road. So yeah, that can be reprioritized on a whim.
Do you have, not that I don't love talking to customers
Mhm.
when they have issues, but if they wanted to reprogram their loads and whatnot, do you have like little video trainings or whatnot on your website that they can access so they
We do.
can, if they've forgotten all of our lovely
Yeah.
points, they can
And-
look at it themselves and figure out how to do it?
Let me.
Kind of like a pared down version you're saying, like
Yeah.
just the nuts and bolts.
Yeah, how to reprioritize.
So this is actually our app live, and right here, this is present on the mobile version as well. We have our quick tips, which will redirect, if we're lucky, to all of our general usage YouTube videos. And then, of course, we do have a full-time tech support team as well. I'm the junior member of that team, and then we have some real industry veterans that are there. So it's a 9 to 5. It's not a 24/7, but we do have a full support tech team. Okay, now I'm totally lost which screen I'm on. We're gonna cycle through for a little bit. Okay, any questions about the interface?
Can you set like trigger levels on each circuit and then get a notification if it goes outside of that trigger?
That's an interesting question. No, I don't think so. Give me a little bit about the use case and let me double check.
You could monitor and trend how much you're using on a circuit, and then you want to know if there's like a big jump on something. I don't know, maybe it could be a motor going bad.
You can see it. So like we do provide historical data. Let me log in and I'll show you one of my coworkers' systems. And so, sorry, tell me your question one more time about setting parameters.
Like setting trigger levels, like
Right. Okay, so we don't have any triggers, but you can do appliance analysis just based on historical data. So let's say we wanted to look at the air handler. You can set the time period to like the last 365 days and kind of, look, is it using more energy over time? We don't have a specific trigger to say like, hey, this appliance might not be healthy, but you can definitely look at it and kind of use your best judgment. It is a lot of data, so this takes a bit of time, which we're all happy to wait for.
Maybe you should ask for a year.
Well, he also may not have installed it a full year ago.
It looks like it samples per 5 seconds. It's a-
Yeah, that is a lot of data.
Yeah, great, thanks guys. No, actually the measurement is being taken 15,000 times a second, and then we pump data every second. So
So how quickly, what is the time for load shedding? Like how
70 milliseconds.
70?
70 milliseconds, yeah. Now there are a few transfer switches. Well, actually no, most transfer switches are fine, but there are a few microgrid interconnect devices that transfer a little bit slower. And we have had a few ride-through issues where the transfer has been slow enough that the lumen has lost power. And then, of course, no load shedding happens at all. And for that, we do have a plug-in temporary power unit, just a capacitor, as an extra purchase. So if need be, there's a port for it, and now you have about 100 seconds worth of power. And that should get you through any ride-through issues. So most systems are going to be fine. Specifically, the SolarEdge backup interface, for whatever reason, takes about 2 to 3 seconds to ride through, which will definitely kill our power supply. So almost all SolarEdge projects are going to have that backup capacitor. And so yeah, this is an example of the kind of real-time monitoring. This is updating every second. Every time it goes into dot mode, it's giving you new information. And then at least I know you can look at it over the course of a week, and you can see kind of what the appliance has been using. So for any real energy nerd customers that you have out there, this is going to be a great way to have a 2-hour tech support call. Yeah, actually, that's a promise, not a threat. We take those calls. No, we're happy to do it. Yeah.
How is it powered? What can, where does the...
Oh, so it is a 15 or 20 amp dual pole breaker landed in whichever service panel is being powered, or whichever load center is being powered.
How much power does it actually?
It has a standby wattage, or like a phantom load of 6 watts, and then I did the math out just the other day. I think the maximum wattage, if all of the relays are running at the same time, is like 49, 50 watts. So it's a pretty light load. It should justify itself. You know, it uses like less than 100 watt hours. But yeah, it's a pretty light load. It does have a standby wattage of 6 watts.
How long do the capacitors ride it through?
So if none of the relays are activated, we've had it go up to 120 seconds. If all of the relays end up being activated, it will cut that down to about 30 to 40 seconds. Either way, more than enough time to ride through. And really that 40 second threshold is what we're looking to achieve in case someone's backing up with a generator, which may take a little bit more time to spin up. Okay, that's it. That's our product demo. This is all of our team's contact information. This is just our sales team. And then if you want to call technical support, actually, if anyone wants to make us look really good, you can call the number now. I guarantee they'll pick up.
Everyone at once.
On 3.
Yeah. Or it'll ring on my phone. I think I set myself to unavailable, but let's not test it actually.
Did you guys come out of the solar industry? Like the
Yeah. Well,
come from the solar industry?
kind of.
Or from the energy side?
Well, so our founder is actually an ONG, exile, but most of the staff is comes from the solar industry. Mm-hmm. So our tech support team entirely from the solar industry, our sales team entirely from the solar industry, and some of the software team we're taking from other odd ends of software world, but no, largely solar. Yeah.
In backup mode, do you have any insight into available capacity of solar that isn't being used because it's only delivering what it needs?
Huh. Potentially. So we do have multiple CT ports, and so you can run an auxiliary CT and measure the PV. So you could look at it in real time and say like, well, this is not the size of my PV array. What am I losing? But nothing that's like a trigger to say, hey, you're missing this much utilization or something like that. But you could see the data. Any other questions? Yeah, please.
I understand that SolarEdge is obviously not the preferred Lumin best friend.
No, we love
to its
SolarEdge.
transfer, but do you have like your number one recommendation for a backup system?
No.
That works with Lumin?
No. Genuinely, the idea is to be agnostic. We work equally well with any equipment. The only state of charge. Well, actually, I can show that to you. I'll have to reset some of the settings, but we do have state of charge monitoring. Like I said, it's only with SolarEdge and Enphase. So let's say we set this threshold to, 80%. We want the AC. We have the ability to run it, but once the battery goes below 80%, well, let's go into survival mode, right? So if we simulate an outage, let me bump the timescale a little bit. So you can see the battery system is using the battery capacity, and once we get to 80%, the AC will kick off. So we can do that, but we can only do that with SolarEdge and Enphase. So really, SolarEdge is like one of the more robust integrations that we have. It's just every install with Lumin for SolarEdge is going to require that extra capacitor as well. So they tend to be a little more expensive, but it's a great integration. But no, there really is no preferred inverter, battery, whatever you want.
Is this capacitor something you guys sell, or
Yeah.
is it an option, or do we install it?
I mean, yeah, you would install it. We do sell it. So it's really cute. It's just like a little baby Lumin panel. Has our logo. It looks exactly the same as the smart panel. It's just really small, and it is just a wire and a plug.
Ballpark, how much is that?
350. Yeah, it's 350. But yeah, please. Anything else?
How do you protect your supply side connection wiring? It looked really simple.
Right. You know, I am going to do a little bit of a kick to the AHJ, but if it's a supply side connection, the conductor coming out of our conduit is 12 gauge, so you're definitely going to have to upsize to 6. And then, you know, whatever OCPD is required from there,
So there's more to it.
please talk to your local inspector, make sure that it won't pass inspection. But yeah, that's the most complex part of the installation, and the part of the installation that will most likely require professional assistance. That being said, if you have someone that has a partial home backup or a critical loads panel already and they want to add a Lumin panel, you can land, instead of a supply side connection, you can land that voltage reference as a breaker in the main loads panel. Since the main loads panel will not be getting power, that's a nice, friendly DIY way to do it. But yeah, if you have to make a supply side connection, well, you know, call in someone who knows how to make a supply side connection. Please.
It senses loss of grid. How does it sense return of grid?
Same way. It's just a true false statement. If there's 120 volts coming in on the reference, we say grid is there, grid is true, and if there's 0 volts, then it's false. Grid is not there. So as soon as the grid comes back on, well, shouldn't say as soon as. Of course, we have a 5-minute timer before re-energizing loads, just like everyone else. But yeah, after 5 minutes of grid return, then all the circuits will be re-enabled.
If you're tapping it in ahead of the critical loads panel,
Mm-hmm.
and this is a system which intends to have a backup power, that's the panel that is going to continue to stay powered by the inverter that's kicking on to
Mhm.
run your critical loads. Wouldn't it see that as the grid, and it's not acting anymore? Or is it just perhaps I'm interpreting what your device does incorrectly, but if it's going to operate for smart loads
Mm-hmm.
and be able to take out some of the loads that are going to be too energy hungry,
Mm-hmm.
you have it cued into perhaps shutting those loads down when there's a grid loss.
Correct.
It's getting that information by what's flowing through the wires going to the sub-panel, in the sub-panel situation.
Mm-hmm.
But the sub-panel is exactly what's being powered up by the generator or the backup system in
Right.
the event of a grid loss. So it sounds like then you've defeated the purpose of shutting down smart loads, if that's what its cue is, of how it knows to shut down those loads.
The reference would be on the main panel, right?
Yeah, in a critical loads panel, the voltage reference would be in the main service panel. If you're backing up the main service panel, the voltage reference would be on the supply side. It has to be any de-energized place. If it has energy when the grid is available and doesn't have energy when the grid is unavailable, that's where the voltage reference needs to go.
It can be the other side of your transfer switch.
It can be. AC disconnect is also a common location.
Do you have a picture of the inside of one of your devices?
I do. I mean, this is like very much a, it's a marketing rendered exploded view.
I meant an installed one with its wired so we can see what it looks like.
Yeah, I do. But I'm not sure that I want to show you guys how disorganized my files are.
It'll be in the booth, right?
Unplug it, find it, plug it.
No, talk to me afterwards. I definitely have pictures on my phone, and then I'm pretty sure I have it on my computer too. So yeah, I can show you the inside. It also is our IP, so maybe I shouldn't broadcast that everywhere. But I'm happy to show you. That's no problem.
Good public speaking move there, by the way.
Well,
Kind of dodging that question.
I'm learning.
Yeah, right.
So I guess in theory, we don't have to go inside your panel. Is that what you're saying?
Yeah.
Because all the wires are external.
Yeah, you do not have to take the cover off. Although, if for some reason you have to rotate it, the cover can come off, and we do ask that you rotate the logo. Right side up.
You gotta make it look nice.
It'll give you another sticker to put it lay over it.
Oh, we don't do stickers. No, it's we do stickers. No, so we did. We got called in last minute, so we have a scant amount of swag. Really, just our tech specs is all we brought. But see us at Intersolar, NABCEP conference, or RE Northeast, and we'll get you stickers. Okay, unless there's any other questions, which I'm not leaving after this. I'll be downstairs. So if you do have questions, please feel free to come and see me. But otherwise, guys, thank you so much. This was terrifying. Thanks for having me.